Today's lesson is how to determine if two ratios are proportional. Does anybody know a different word for proportional, like a synonym, a word that means the same thing as proportional in math? So if I'm looking at these two fractions, I could say not only are they proportional, what else would they be? Starts with an E. Equivalent, right? Equivalent fractions. So that's what we're talking about. Are they equivalent? Are they proportional? There are three ways to decide. You can use any of these three ways. I'll tell you the one that is probably going to be the best to use. But method one is to simplify the fractions. If they have the same simplest form, then they are proportional. So let's simplify 10 24ths and 25 60ths. So 10 24ths. How would we simplify that fraction? Remember, we have to find a number that divides, that goes into both 10 and 24. What do you think? 2. Let's divide by 2. So 10 divided by 2 and 24 divided by 2. And that equals 5/12. Is that in simplest form? Yes, well 5 is a prime number, so the only two factors are 1 times 5. Dividing by 1 does not help us because it wouldn't get any smaller. It would still be 5/12. And does 5 go into 12? No, it is not a multiple of 12, right? So that is simplest form. Now let's simplify 25 60ths. What are we going to divide the numerator and denominator by, Camden? 5. 25 divided by 5 and 60 divided by 5. What do we get? 5/12. And that is simplest form. We already talked about why. And it says if they have the same simplest form, they are proportional. Do they have the same simplest form? So what will we say? They are proportional. Now, do you think that's going to be the easiest method? You do? Do you guys like simplifying fraction after fraction after fraction? Not usually. I mean, you can simplify it on a calculator. That makes it better. But that is not normally a method that people prefer. That is not normally what they like. So I'm going to just go ahead and highlight my two answers that show, so that if I look back, I can see it. And they are proportional because they have the same simplest form. Ready for method 2? Method 2 says to find the unit rate. If they have the same quotient or unit rate, they are proportional. So these are not very nice and neat for the unit rate, but let's find it. 10 divided by 24. So to find the unit rate, we divide, right? Quotient right here means to divide. And so on a calculator, 10 divided by 24. And we get decimal 416 repeating. And where am I going to draw the repeating bar? Over the 6, right? So because this 6 repeats, we only write it one time and we draw the bar over that. And does this repeat if this ends in a 7? Yes, remember we talked about on the calculator how it's called truncates it. It just kind of chops it off and then it rounds. And so if this was a 6 over here, it told that to round up to a 7. So it just kind of chopped it off. All right, and then now we are going to say 25 divided by 60. And we're going to do that same math. They should be proportional because they were up at the top, right? So it was 25 divided by 60. And we get, is that the exact same number? Yes. Decimal 416 repeating. So what would our statement be? They are proportional. That is method 2 to divide. If you get the exact same number, they are proportional. All right, this last method is usually the preferred method. I'm going to put a star next to it. It's usually the easiest. And it is to cross multiply. If they have the same cross product, they are proportional. What does that mean, product? Answer to the multiplication question. If they have the same answer, when you multiply, they are proportional. So you just set these up as 10 over 24. Does that equal, is it equivalent to 25/60? That's the question. And this is how we check. So we say 60 times 10. Well, I can use mental math. 6 times 1 is 6, and move 2 zeros over. So we're going to get 600. That's our cross product that way. And let's cross multiply that way. 24 times 25. 24 times 25, and you get 600. Did we get the same cross products? Yes. So we would say they are proportional. Which way do you think was the easiest? Yes. Does anybody know why cross products work? Anybody know why cross products work? So let's just take a look here. I want to find 10 over 25 and 25. Oh, no, that's not 10 over 25. What is that? 10 over 24? 10 over 24. And 25/60. So this is saying If I said times 60 times 60, if I wanted to make an equivalent fraction, this is 600 over 24 times 60, 1440. So I took this fraction and multiplied it by this denominator. And so then I would take this fraction and multiply it by this denominator. And I'm going to get 600 over, well, if this is 24 times 60, 60 times 24 is 1440. This is where that 600 comes from. What we were doing was we were making, do you remember when we were adding and subtracting fractions? And we did that cross this way, and then cross this way. And we said 24 times 60. It's the same thing. What we were doing was we were finding equivalent fractions that had a common denominator. So if I use the common denominator of 1440 for both of these fractions, then they're going to get the exact same numerator, 6 over 1400 and 6 over 1400. That's why those are the same, and that's why cross products work. Because really all you're doing is you are making an equivalent fraction and using a common denominator. Questions about any of these methods? I think that although some of you may like this method the best, this one is going to be the quickest and the easiest. This one is going to be the one that I use to demonstrate because we use cross products so frequently that we're familiar with it. Okay. All right, let's look at the skills practice, and then we'll put that in our journal. So skills practice. Non-proportional relationships. For exercises 1 through 3, use the table of values. Write the ratio in the table to show the relationship between the two sets of values. All right, so we've got a situation here where we see the number of hours someone worked and the amount of money they earned. What would we call this number right here? 1 hour is $15. What would we call that? So $15 in 1 hour. What would we call that? What do you think? Right, but in math, what do we call that when it's for one of something? It's the unit rate, right? So this right here is the unit rate. So we could use this unit rate method and see if we get the same unit rate every single time. Well, if this is 1 hour is $15, 2 times 15 is 30, 3 times 15 is 45, 4 times 15 is 60. Do you think those are going to be proportional? I think that they are, yes. But you can also tell, we could write the ratio of, I'm going to change mine to $15 for 1 hour because I like the unit rate to look like a unit rate. And $30 for 2 hours, $45 for 3 hours, and $60 for 4 hours. So I've already determined the math that I did here when I said times 15, times 15, times 15. I've already determined that they are proportional, but you could use cross products. 2 times 15 is 30. 1 times 30 is 30. So that makes these two proportional. Then you have to keep going. 3 times 30 is 90. 2 times 45 is 90. That makes these two proportional to each other. And then I can say 4 times 45. I don't know that one off the top of my head. 4 times 45, 180. So that makes 4 times 45, 180. And 3 times 60. Well, 3 times 6 is 18. And then put that 0 over there. I also get 180. So these two are proportional to each other. So would these all be proportional? Yes. All right, let's look at the next one. So one package costs $11. 2 packages cost $10. 3 packages cost $29. And 4 cost $38. What's your feeling? Do you think those are going to be proportional or not proportional? I don't think they are. Why? Can anyone tell me? What do you think, Anna? Right, it would be 11 times 2 would be 22, right? So if I do this, I could say the unit right here is 11 for 1. Here, 20 over 2 equals how much for 1? What's 20 divided by 2? 10. So if 2 of them are $20, then one of them would be $10. Those two things, this and this, are not the same. This one has a higher price per package. This is $10 for one package. This is $11 for one package. All right, $29 for 3 packages is how much for one? Well, I feel like we need to do some math here. 29 divided by 3. $9 and is money. What would that be? 66 cents or 67 cents? 67, right? That 6 is going to tell that to go up to a 7. So $9.67. So it seems like the more we buy, the cheaper they're getting. And so $38 for 4 is how much for 1? $38 divided by 4 is $9.50. So these were proportional. And we would say these are not proportional. I'll leave you this one to do on your own. Down here at the bottom, it says use the table of values, write proportional or not proportional. So you can either cross multiply or you can find the unit rate for those. And there's a word problem down there. All right. Number 8 says use a table of values. That means you need to create a table that looks like this. So it is, Fred is ordering pies for a family reunion. Each pie costs $4.50. For orders smaller than a dozen pies, there's a $5 delivery charge. Is the cost proportional to the number of pies ordered? So, money, number of pies. So I would say you probably need to have something here. How much does one cost? How much does 3 cost? How much does 9, 12, and 15? And you're going to have to do the math. Does anybody know why I picked those numbers according to the problem? For orders smaller than a dozen, there's a $5 delivery charge. So down here, you have to pay for the pies and a delivery charge. And up here, at a dozen, am I still paying the delivery charge? No. So you've got to figure out the math that goes in that one. So we're not going to do this right now, but I did set it up for you. You need to make sure you have that written. All right, so we really got to think about what this means as we fill this chart in. So each pie costs $4.50. So this first pie is $4.50. Am I going to have to pay a delivery charge? How much delivery charge? So that makes, if I just order one and they deliver it, that means I'm paying $9.50. So that's my unit rate. If I order 3 pies, how much is each pie? $4.50. So the pies are $13.50. Is that less than a dozen? 3 pies? Yes. And so am I going to have to pay a $5 delivery charge? Is it $5 per pie or $5 no matter how many they bring me? No matter how many they bring me. So I just have to add $5 one time. So that makes the 3 pies $18.50. Can I already tell those don't look proportional? One here is $9.50. 2 of them would be already more than that, wouldn't they? If I ordered, so I'm getting 3 here. That looks like a unit rate of what? $18.50 divided by 3. That made my unit rate $6.17 for 1 pie. But here my unit rate was $9.50 for 1 pie. Why is this so much cheaper per pie than this one? Well, this was taking the $5 cost all by itself, right? This right here was spreading that $5 out between how many pies? 3 pies. So it's a lot cheaper to order 3 and spread the cost out. What do you think about this 9? What do you think that's going to do? Is it going to be cheaper per pie? I think so. So it is $4.50 times, how many pies? 9. And are we still paying a delivery charge? Yes. How much? $5. So 9 of them, that makes those $45.50. Is that even cheaper per pie? So let me add the $5 there. And then now let's divide it by 9. And so now it's really just $5 and how much? 6 cents per pie, right? So this is $5.06 for 1 pie. So it's getting cheaper because these 9 pies shared that $5, right? Here, this 1 pie paid the $5 all by itself. Now, at 12, are we still paying the delivery charge? No. So $4.50 times 12. And that's $54. What's the unit rate on that one? $4.50, right? It already told us up here because we're not paying the delivery. So $4.50 for 1 pie and 15. $15 times $4.50 is $67.50. But how much is 1 pie there? It's still just $4.50, right? The same unit rate because we're not paying for delivery. Does that make sense? So whenever you have a delivery charge or a charge that's a one-time charge, that's going to make your problem not proportional. Whenever you have a delivery charge, or if you've got to rent a car for $50 and then pay 17 cents per mile, that $50 is going to make all those miles not proportional. So we would say not proportional. So that's one of those indications when I see a delivery charge, I automatically know not proportional. It's going to change your unit rate. The more things that you order with that delivery charge, the cheaper it is per item. Questions? All right, let's look at a couple of the word problems on the back. Sports. A touchdown is worth 6 points. Additionally, if you score an extra point, additionally, you score an extra point if you can kick a field goal. Is the total number of points scored proportional to the total number of touchdowns? So what do you think? Have you ever seen a football game where somebody missed the extra point? Yes. So that makes it not proportional. The total number of points, can you only score on a touchdown and an extra point? You can also get a field goal that is worth 3 points later in the game. You could a safety for 2 points, right? So would the number of touchdowns always be proportional to the score? No. That's all you have to say. No. If you could only score 7 points every single time for a score, would they be proportional? Yes, if that was your only option. If you could only score 7 points, then yes, they would be proportional. Let's look at the next one. An outdoor swimming pool costs $8 per day to visit during the summer. There is also a $25 yearly registration fee. Is the total cost proportional to the total number of days visited? This is like that last problem. What makes this not proportional? I'm going to tell you it's not proportional. The $25 yearly registration fee. So if you only went one day, it's going to be $8 plus $25. If you went 2 days, it's $8 plus the $25. If you went all 365 days, you would pay $8 and the one-time $25 fee. So that $25 registration fee means they are not proportional. Okay, so I'm going to leave you to think about those. So all you really have to do is number 3, 4 through 7, which is similar to these. You're just going to determine if those are proportional to each other. And then you have 4 more back here to just decide, are they proportional, yes or no. That's it. Yes, question? Number 4 on this side? Yes? Okay. A baseball club has 18 players for every team, with the exception of 4 teams that have 19 players each. Is the total number of players proportional to the number of teams? No, because some have 18 and some have 19. So, no, they cannot be proportional. If you had one team at 18, two teams at 36. If it always remained the same, but what happens if the next team has 19? Is this going to go up by 18 again? No. So no, not proportional. If those are different, not proportional. All right, any other questions? Okay, you've got about 20 minutes to work on this. If you've not finished your warm-up, finish that, get it turned in. You do have a guide. Oh, we need to put these in our journal. Sorry. So we are on page 53. Page 53, and you just glue that on. I'm going to abbreviate the second word. 1118, proportional and non-proportional, and that's page 53. All right, once you get that taken care of, you can work on finish your warm-up, and then work on your skills practice, and then have your skills practice checked by a teacher when you're done.